Good day everyone, Brian Carson here. Today we're going to look at the respiratory system and more specifically the process of alveolar gaseous exchange. As we know, we take in air through the nares and the mouth. This passes down its pressure gradient through the trachea, bronchi and bronchioles and eventually into the alveoli. The oxygenated blood passes through the pulmonary circulation from the pulmonary artery to the capillary beds and back to the left side of the heart via the pulmonary veins. This blood has a high partial pressure of carbon dioxide and low partial pressure of oxygen. Carbon dioxide is transported in three forms: bound to hemoglobin on the erythrocyte, as hydrogen also bound to hemoglobin, or as bicarbonate dissolved in the blood. In the alveoli, the partial pressure of oxygen is high and carbon dioxide is low. As this blood reaches the pulmonary capillaries and comes in proximity of the alveoli, this partial pressure differential causes oxygen and carbon dioxide to move down their respective pressure gradients and diffuse across the respiratory membrane. Carbon dioxide moves from the capillaries out to the alveoli, and oxygen moves from the alveoli into the capillaries. Oxygen then binds to hemoglobin on the erythrocyte to form oxyhemoglobin, depicted by the change in colour from blue to red. This oxygenated blood returns to the left side of the heart via the pulmonary vein and from there out into the systemic circulation for gaseous exchange with the tissues. If we look at that process again, the erythrocyte carrying carbon dioxide passes through the capillaries. Carbon dioxide moves down its pressure gradient and into the alveoli. Oxygen moves down its pressure gradient and into the capillaries, where it binds to hemoglobin to form oxyhemoglobin. So, how is this diffusion of oxygen and carbon dioxide facilitated? The alveolar and capillary spaces are separated by a very thin barrier known as the respiratory membrane. So let's take a closer look at this. The respiratory membrane is made up of a single epithelial cell layer as part of the alveolar wall. As with all epithelial cells, this is accompanied by a basement membrane. On the capillary side, there is a thin layer made up of single endothelial cells. This minimal barrier allows carbon dioxide and oxygen to readily diffuse across the membrane down their partial pressure gradients. This was the process of alveolar gaseous exchange. I hope you found this a helpful learning tool. Please provide feedbacks in the comment section if you wish, and I hope you all have a great day.